My name is Pavel Tomancak. I was born in Czechoslovakia, and I started my studies in Czechoslovakia and ending them up in Czech Republic. Right, so that's maybe interesting thing to say. I studied in Brno, molecular biology and genetics, and then I, came to EMBL, and in fact, it's been fairly well established that I was the first Eastern European PhD student who joined EMBL. I joined Anne Frusi and did my PhD here. After that, I went to America, to California, to Berkeley. I worked in lab of Jerry Rubin, and from there I came back to Europe, to Dresden, Max Planck Institute of Molecular Cell Biology and Genetics, where I am a research group leader until now, basically. And very recently I also started kind of close the circle, and I got involved again back with my alma mater in Brno in Czechia, where I became the director of the Central European Institute of Technology, CEITEC. The director is a little bit of a misnomer. I'm more or less a president. I do that about 20% of my time. And it's a more political job than scientific job, but nevertheless I'm trying to give back to my country where I came from.
So maybe let's start from your beginnings at EMBL, because you said something very interesting. You were one of the first students coming from Eastern Europe. I think this was more or less the time at which the EMBL was shifting from, let's say, employing mostly people from member states to really opening up.
Right.
So do you have some thoughts about that? Do you remember something about being, one of the first coming from the eastern part?
Well, I think it was really like, when I ended my studies in Brno, I really saw the advertisement for EMBL, EMBL. And already EMBL at that time was kind of a legendary place. It was the mecca of molecular biology in Europe. And for me, it was a, I would say rather extreme adventure to actually apply for this program, because, you have to realize that before coming for the interviews here, I have never really spoken English kind of to anyone more than, few words as a tourist, right? So it was a, big step. Nowadays, students who graduate from universities in Eastern and Central Europe, they speak perfect English, right? My first experience of speaking English live with somebody was Steve Cohen. I didn't understand a word of what he was saying, but we had a nice conversation.
Very, very nice. I remember Steve with his Canadian accent. Yeah, also for me it was quite hard to understand everything at the beginning. But then you chose, and you were chosen by the group of Anne Frusi. So how did you see the EMBL when after you had the knowledge of the EMBL when you came there, and how did you go about finding the right lab for you?
Yeah, so I mean, how these interviews, I think until this day, are very concise, and in 1 week you basically have to make the connection, right? So I would say that probably the best thing to say is that Anne Frusi simply gave me a chance, right? But overall, I had a really, at the end, in fact, when I got over my, let's say, anxiety at the beginning, I actually really enjoyed the interview process. I mean, the people I spoke to were very open, very kind of tolerant to my broken English at that time. And I saw this is a really good place, to come. And when I then was in the train coming back home, I was actually looking at Anne's publications at the time, and it was pretty amazing, actually, because that level of science, I was not exposed to before.
Mm-hmm. And you were also new to model system biology and development, right?
Pretty much, yeah.
Okay.
Yeah,
so how did you enjoy picking up such a field and such a system that you are still using to this day?
That's maybe a good question that you asked that, because I think, it was really interesting time to come to EMBL, because so I started my PhD in '95, right, which was the year where Jan Nislen Volhard and Eric Wieshaus got a Nobel Prize for their work on Drosophila, right? So this was really a good time to step into that field, you know, to start working in developmental biology in a lab, you know, which is focusing, you know, absolutely primarily on Drosophila. So that was really great. And then, you know, even during the time when I was here, you know, we moved the lab to a new building, which was actually named after Yanni and Eric. So you know, I think those were really, to some degree, the golden days of developmental biology at EMBL, and that was really exciting. And so I was very fascinated at that time about development, about how organisms develop from single cells. I didn't really at the beginning know much about it, but I was quite convinced that that's what I want to study rather than molecular biology. So for me it was a really you know, great career move to come here.
And I remember, I mean, your project was a very exciting one, also because I inherited part of it when I came to the same group. And it was really at the core of understanding how the embryo essentially gets started, you know, how the polarity axis was determined. So really exciting, intellectual, fundamental biology question about it. But then after the MBL, you moved to the US, so to UC Berkeley, where we also partly overlapped, as you said, to the group of Jerry Rubin. And how did your scientific interest shifted when you went to America?
I think that you know, it's when I came to Jerry's lab, you know, I was really, there was at the time where DNA microarrays have been kind of introduced to the scientific community as a tool to measure gene expression in parallel for many genes, and I was quite fascinated by that technology. I started working on that, and so in principle that really kind of shifted my focus from developmental genetics, from, let's say, more classical mutation studies of specific genes or pathways to more towards genomics. But you know, I actually very quickly shifted to yet another aspect of how genomics can be done, and by essentially looking at gene expression not by measuring quantitatively many genes in parallel, but more to visualize when and where genes are expressed in development. And I got involved in a very large-scale project to map the patterns of gene expression in Drosophila embryos by RNA in situ hybridization, and that led me first of all to rekindle my interest in computational biology, in programming, in web development, databases, and so on, which I had as a teenager. But you know, when I was at EMBL, I was not using it all that much. So that was one thing, and then I started really thinking about imaging. At that point, high throughput imaging, but that really prefigured what I did in the rest of my career.
Yeah, so I think it's a very interesting trajectory that you had, because in a sense, you, as you said yourself, you went from a single gene to like looking at many things in parallel, and then you know, this was more or less the time where data science was like booming and still booming, I would say. Yeah. And then, as you said, you went to also reconsidering computational biology, and the technological aspect is an aspect that you have developed a lot, right? When you moved to Dresden, there was a lot of instrument development as well. This was something that, you know, was done also in connection with the EMBL. Is something where EMBL was useful for you? When
I was in Jerry Rubin's lab, towards the end of that, let's say, stay, I mean, Jerry was building Janaria Research Campus, but he would, you know, once a month come back to Berkeley and talk to us. At that time, Ernst Stelzer has published a paper on SPIM, on selective plane illumination microscopy, which now is more referred to as light sheet microscopy. And I got extremely excited about that paper. And when Jerry came, I went into his office with the paper printed, and I said, Jerry, this is the future. And at that time, Jerry was like, okay, yeah, that's very interesting, I have a look, but you know, please continue
to do your stuff.
The screen. So then when I came to Dresden, very soon an opportunity came to actually reconnect with the technology development in the light sheet field through the ZEISS company and so on, right? And I have actually, I would say this was a very important turning point in my career. I have not really developed light sheet technology, but I've really systematically tried to utilize it in my research, and that led me to develop tools of computational image analysis, and that essentially led to the establishment of the Fiji project, which obviously had a big influence on my career. But as this was kind of happening, Jerry Rubin, some years afterwards, came to visit. And you might be aware of the fact that John Elia has then very heavily invested in light sheet microscopy technology development and utilization. And Jerry, when he visited, he came to me and he said, "You were right. This really is a game changer." And I think it's really important. It came from EMBL, Ernst, his co-workers. They should absolutely be credited for this revolution in developmental biology.
Yeah, and I think for relatively large organs and samples, this is really key, and considering the efforts on the coding, the brain architecture at Janilia, this was actually a very, very great insight into that. And in your lab, as you were mentioning, you also made a lot of these tools available. I remember just on the top of my head, the instruction to actually build a light sheet microscope from your lab, like you could do it in your basement. And this idea also of a lot of tools for imaging that I think were, great in the sense that it was another example of being freely available to the community without having to pay any subscription. And, considering that some people were, using proprietary softwares attached to a microscope. Fiji has been essentially a revolution. It's eating up every sort of format and can analyze, very flexibly in many, many situations. So tell us a little bit more about that.
Yeah, so I think investing in open science was the best decision in my career. Early on, what actually was really instrumental was that we were, I absolutely have to say we, because I was very lucky to recruit, very talented students who had really professional computer science background. And we were developing software which we were immediately putting out there for people to use, right? And it was a good software, and people used it. And after that, it was actually extremely easy to publish it. We were usually, when we finally, put everything together to make a publication, we basically got, very positive reviews. And after one round, we had the publication ready, because the people who reviewed our publications were people who were using our software on a daily basis, right? And I can recommend that very much as a strategy that really works, to kind of help jumpstart your scientific career. Of course, at the same time, I then also started to shift away from this kind of technology development in the field I don't really have very much to say about, which is, computer science and image analysis. I started to shift towards actually using that technology for answering questions in my research, and it's been really good, to be connected to this very, good and active light sheet a community of technology developers, of physicists, of biologists, of computer scientists, and it really brought my research to a next level, because I was really able to utilize the full potential of that technology.
So is this openness and the insight of distributing freely things something that you can trace back to the EMBL? Because of course we had a few interviews already, and we've spoken to Toby Gibson, Des Higgins. This is a tradition of the EMBL. The algorithm would be posted out in the mail initially. So it's something that you consider because you were exposed to this culture at the EMBL, or it's something that you brought with you from the beginning?
Interesting, yeah. So I was been thinking about that. Where was this origin of being in my case, so receptive to open science, right? And I think it kind of involves EMBL, but at the same time, it also involves Jerry, right? Because when I was cloning the gene, which was really important for my PhD and then for yours as well, PAR1, as you know, it is an extremely complicated gene locus. It's large, it has many exons. And with the technologies we were using back then, it would take us a year to basically walk across the chromosome, sequence everything, figure out the structure of the gene. And I started doing that, but then Jerry was sequencing the Drosophila genome. This is even before he teamed up with Venter and did it in a month, right? They were sequencing it systematically, and he happened to sequence a phosphate which contained the PAR1 gene, right? So basically I was just, and they were obviously sequencing and they were putting the sequences immediately the next day on the server, right? So all I had to do was every day come to work, download a few more sequences from Berkeley and assemble my locus piece by piece, right? And that's, you realize, that really is a game changer, because they could have also sat on this data.
And you were referring to your institute, the MPI, who I guess it was set by many people that have been at the EMBL, including you, and now you're a senior scientist there. So, how did you guys go about building an institute using some of the principles of the EMBL?
Right. Yeah. So I came actually a little bit later, so I can kind of only hear how the beginnings were. I think what really the directors, the founding directors did very well was to take the culture of, in particular, the cell biology program here at EMBL and immediately transplant it to Dresden. I mean, they really, the first week they arrived, the most important thing for them was to organize a big party, right? And then when I came, this kind of party culture continued, making movies, making sketches, like in general, kind of having a very cohesive scientific community. I think that was very, very good. And then I think the other thing which really distinguishes Dresden is that we are really communicating really intensively on the scientific level among each other on the level of the PIs, right? So, we really have weekly chalk talks, and I always say, now it's a little bit bigger, the faculty, so some of the theorists I maybe cannot do that anymore, but before I was able to give talks of my colleagues. If they would be sick, I could step in the conference and I could give a talk for Andy Oates or C.P. Heisenberg, because I knew what they are doing, because we were talking about it all the time.
This is really amazing. And but it's a nice.
Maybe a little bit exaggerating, right?
No, but the concept. I mean, I know what you mean, and I think it's a very interesting concept. Also because it leads me to maybe ask you another question about size. I mean, you mentioned now the institute is a bit bigger. Maybe it's difficult to do it, and this is something perhaps that we can reflect also on the development of the EMBL. So, do you think this is something that can be done because the institute is relatively small and nimble, or it's something more cultural that you can try to develop anywhere at any scale?
Yeah. Well, I think it's really I think it's something which is really difficult to maintain as you grow, right? Because obviously, if you compare EMBL at the time when I left or when you left to what it is now, what you really notice that it is not only bigger, but that the portfolio of activities has really diversified. When we were PhD students, we kind of roughly knew what EMBL stands for, what it does. It was mostly about science. There was a little bit of outreach, of course, right? But a little bit of the service for the community, but on the forefront was always science. And now it probably is still the case, right? But the portfolio is really complex, right? And that requires processes and I think a little bit of this spontaneity and creativity which we were experiencing, now is it's not easy to maintain it, right? So I would say that what EMBL maybe actually kind of needs is to still maintain a little bit space for this kind of bottom-up activities, right? And I would say the same thing for CBG, right? I mean, it's when you are bigger, you become an organization which needs some kind of structure, but people's initiatives should still be kind of valued because those are the things which actually will happen.
So maybe as we are approaching the end, a few other questions, because of course, you know, you are having a great career in Dresden, and you mentioned the institute in Brno. So maybe one question about how is it to take on the job of coordinating politically an institute?
Yeah, well, what I'm learning is that you know, every institution is different, right? That you know, it's actually you know, fairly naive, you know, that you can really take the culture of one institution and implant it into another, right? Because every institution has its specific challenges. It's a little bit probably too early to tell. I mean, what I'm really trying to do, Brno, is to connect them more explicitly to the kind of international scientific community. I mean, they actually are. This is probably the best science research institute in Czechia. They have international people. They are connected to all the networks, right? But I think that, you know, their ambition is really to play the Champions League of science, right? And for that, you know, they still need to kind of, you know, be able to attract more competitive international talent, right? And that's what we are trying to do, and it's not easy. We are trying to, you know, get support from European Union, and we are trying to get support. So that's not working so well, I must say. We are, even though the European Union has built up this entire institution, but what I'm actually trying to also establish is to, you know, provide some support. I don't mean a financial, more kind of advisory and cultural, let's say, from institutions such as Max Planck Society or EMBL, right? And so that's basically what is dominating my time in Czechia now, to make these connections. My kind of, if I would want to sell that in an elevator pitch, I would like Brno to be the place where Max Planck and EMBL come together.
Well, that would be great. I mean, here is your 1 minute. No, I mean, it's wonderful. I mean, you're building links, which is something that you have been doing all your careers, and these kind of links are vital for science, I think. So maybe one last question about your involvement with the EMBL after the EMBL, because you have been very active in the Alumni Association. You are becoming even more active soon in the Alumni Association. So what are your views on what the association should do, and how you know, it can benefit the greater EMBL community? Yeah,
so I mean, I don't know if I can say it, but as you know, I will become now the chair of the Alumni Association. So, you know, I kind of continue my commitment to this kind of, let's say, service. You know, in a sense, what I do in Brno, in Czechia, is I'm giving back to my alma mater, and here I would like to give back to EMBL, which really, you know, by all means has, you know, made me and started my scientific career. I wouldn't be where I am without EMBL, and I think, you know, it's kind of like a little bit of a duty to give something back.